Okay, in this video we're going to take a look at how to solve a GayLussac gas law problem. The question reads, determine the pressure change when a constant column of gas at 2.5 atmospheres is heated up from 36 degrees Celsius to 65 degrees Celsius. The first thing that I like to do is box in my variables and try and label them as best I can. You might have to read the problem a few times, but this one says determine the pressure. I can clearly see I'm going to be looking for pressure here. I'm not sure if it's P1 or P2. I'm just going to label it as pressure. And then it goes on to give me another pressure here. I'm going to label that as pressure. And then it gives me two temperatures. I can see that my temperature is starting at 36 degrees Celsius. I'm going to label that T1. And then I'm ending, once they warm it up, to 65 degrees Celsius. I can label that as T2. So as I read the problem, it says I'm going to start with gas at 2.5 atmospheres. That's going to be my starting pressure. I'm going to label that P1, and we're looking for P2. We want to know the pressure change. Okay, so once I've boxed in my variables, all I see here is pressure and temperature. The problem says nothing about moles. If it said something about moles, I know I would have to use the ideal gas law, so I know that's out. I'm going to be using the combined gas law, and the problem also says nothing about volume. So let me show you what I like to do. I'm going to write out the entire combined gas law just as is. P1 times V1 over T1 equals P2 times V2 over T2. This is the entire combined gas law. But because this problem didn't say anything about volume, I can kind of cover over this volume variable here and ignore it. And like magic, you will see the correct equation just pop up before your eyes. So actually I'm going to use GayLussac's gas law, which is P1 over T1 equals P2 over T2. So this is GayLussac's gas law. I know I'm going to do that because the problem doesn't say anything to me about volume. I can assume it's held constant, so I'm going to ignore it. From here, it's just a simple kind of plug and chug situation. What can I use for my pressure 1? Well, we labeled that as 2.5 atmospheres. What can I plug in for my temperature? Please do not make my favorite mistake. If you accidentally put 36 degrees Celsius down here, please cross it out with a big fat X. You must convert to Kelvin. So instead of 36, I'm going to add 273 to it and use 309 Kelvin. Set it equal to, my pressure 2 is my unknown variable. And then again, don't make my favorite mistake. If you accidentally put 65 degrees Celsius down in the denominator, please cross it out. You have to first convert to Kelvin, so simply add 273. You should end up with 338 Kelvin. And now how do we solve this? Okay. I like to cross multiply and then divide. It's just easier for me. And what I like to do is circle in the two that are across from each other. Those are the two that you multiply. So punch in your calculator 2.5 times 338, then divide by this remaining number, the one that's just hanging out all on its own. Divide by 309, and for your final answer you should end up with P2 equals about 2.7 atmospheres. I guess depending on how you round that. So there's my final answer there. Again, how did I get that? Cross multiply and then divide by the remaining number. This has been a Rodriguez original production. I hope you enjoyed it. Study, practice, good luck.